everyone and welcome back to my YouTube channel. Today we will discuss chapter number 5 for class 10th chemistry, and chapter is periodic classification of elements. So first thing is, what is classification? Classification is the representation of elements with their similar properties so we can easily study them. Today we have modern periodic table, but modern periodic table was developed by the historical attempts of some scientists. So today we will discuss historical attempts of various scientists for classification of elements. First attempt was given by Proust. So first was a Proust concept. According to him, elements were divided into two parts, metals and non-metals. Basically, according to Proust, elements can be of only two types, metals and non-metals. So all the metals are studied under one category and all the non-metals were studied under one category. But this concept has limitation. There is no place for metalloids. Some elements show the property of metals and non-metals and they are called metalloids. So according to this concept, no place for metalloids. Second major limitation is all the metals can't be studied together. For example, we have three metals. Lithium, magnesium and aluminum. They all are metals, but they have different valencies, different oxidation states, different physical properties. Lithium show +1 charge, magnesium show +2 charge, aluminum show +3 charge. So how can we place them in a one category, under one category? Similarly, we have different type of non-metals having different valencies. For example, we have F-1, O-2, N-3. They have different valencies, different properties. So how can we study them under one category of non-metals? So it was the first attempt divided into two subcategories, metals and non-metals, but it has limitations. Limitation: no place for metalloid. Second, all metals and all non-metals can't be studied under one category. After this, there is a second law, Dobereiner's law of triad. After first attempt, second, Dobereiner's law of triad. He introduced a concept of triad in 1817. According to Dobereiner's law of triad, elements are arranged in a set of three elements. So what is triad? Triad is a set of three elements. He used the concept of atomic mass. He arranged elements in increasing order of atomic mass in triads. And what was the criteria of triad? For example, we have three elements. So first thing is, he used the concept of increasing mass, increasing order of atomic mass. For example, we have three elements A, B and C. According to Dobereiner's law of triad, the relative mass of a middle element, the relative mass of a middle element is the average mass of first and third element. So what was the triad law? according to Triad's law, the mass of middle element is the mean mass or average mass of first and third element. It may be close to mean mass or average mass, or maybe exactly same to mean mass or average mass. He gave three examples, and we have now three triads. First triad was triad number 1, lithium, sodium and potassium. If we compare their atomic masses and apply the rule of triad law, the mass of lithium is 7 and mass of potassium is 39. So the mass of middle element sodium and we know the mass of sodium is 23. So it was the first triad of DOBEREINER. And interestingly, one thing more, the properties in a triad were similar. For example, lithium, sodium, potassium, they all are reactive metals. They have a valency 1 monovalent cations, and they quickly react with water to form a soluble hydroxides called alkalis. So somehow DOBEREINER law was applicable to triads because all these three elements have similar properties. All are metals, all are reactive metals, all form monovalent cations, all quickly reacts with water to form a soluble hydroxide. And second triad was second triad was calcium, strontium and barium. So mass of middle element is the average mass of first and third element. Mass of calcium is 40, barium is 137. So mass of strontium according to DOBEREINER's law, the mass of strontium must be 88.5 and actual mass is 88. So somehow similar properties, similar atomic mass is there. Now this triad has same property also. They all are metals. They all form divalent cations, and they are in modern periodic table. They are also even placed in a same group. So it was the second triad of DOBEREINER. Third triad was so according to triad law, mass must be 80 point something and its actual mass is 79.9, almost 80. So third triad was also absolutely right. Now all these three are non-metals. So DOBEREINER gave the three triads. Triads number 1 belongs to first group of modern periodic table. Triad number 2 belongs to group number 2 of modern periodic table. and triad number 3 belongs to group number 17 of a modern periodic table. But what was the limitation of Dobereiner's law of triad? He could not arrange all the elements in triads. All the elements were not placed in triads. Only 3 successful triads were given by Dobereiner. So why it is failed? It was unable to arrange all the elements in set of 3 elements. So after this, a Newland's law of octave come into notice. Third historical attempt was given by Newland, and law is Newland's law of octave. Octave means eighth element, concept of 8. As we know, in Indian music system, we use the concept sa re ga ma pa. Similar manner, Newlands arrange elements in a same way. For example, we have musical notes sa re ga ma pa dha ni, and after again sa repeat again. So he used the similar concept to represent the elements in increasing order of atomic mass. One thing is must be noted here, he used the concept of increasing atomic mass. At that time 56 elements were available, and he arranged 56 elements according to their atomic mass and used the concept of Indian musical beats. So he arranged elements in this way. So Newlands arranged elements in this way in increasing order of their atomic masses, and he concluded that if we fixed an element, then 8 succeeding element will have the similar properties. For example, we have fixed the lithium, so 8th element from lithium will have the similar physical and chemical properties. If we count, the 8th succeeding element from lithium is sodium, and we know both are metals, both show +1 charge, both are reactive metals, both form soluble hydroxides. So somehow Newland's law was applicable to certain elements. For example, we have another example. If we fix the boron and we count the 8th succeeding element from boron will have the similar physical and chemical properties. So 1 2 3 4 5 6 7, 1 2 3 4 5 6 7 8. Boron and aluminium both are trivalent cations, but somehow there were some limitations. If we clearly understand, clearly see this arrangement. There are some irregularities. First irregularity, after chlorine two elements are placed in one slot. How can it possible? And both are metals. Fluorine, chlorine, they are non metals. Second irregularity was there after aluminium, chromium, both are different in properties. After sulfur we have here iron, again this is irregularity. And next, in this group two elements are placed in one slot, cerium and lanthanum. So practically this law was applicable only up to calcium. After this law was totally flopped. No proper explanation why two elements are placed in one slot. And the major limitation was, as noble gases were discovered, this arrangement is totally disturbed. After the discovery of noble gases, this arrangement was totally disturbed. As noble gases were discovered, after fluorine, atomic number 10 will come. So there will be no match between lithium and neon. So it was applicable only up to when noble gases were not discovered. As noble gases were discovered, this arrangement was totally disturbed. This is a third attempt, Newland's law of octave. In next segment, we will start a Mendeleev periodic table. Thanks for watching.